I'm the Director of Identity Security at Microsoft Corporation.
Hi everyone, I'm Sinead Donovan. I run network security in Azure Networking.
And we're going to talk to you today about Zero Trust and the road ahead. All right, so Zero Trust. We want to, sort of set the ground here. When we talk about Zero Trust, we're talking about a set of principles for security that really assumes that we can't infer anything from the environment, that any request can be coming from an untrusted environment. And so we carry three simple principles as we go into this. We look at the first rule, which is to explicitly verify every aspect of a request that you can. The second is to make sure that you have policies in place to enforce least privilege access, to reduce things like lateral movement. And then finally, we want to be humble, and we assume that bad things can happen anyway. So we're going to be very focused on things like automation and great telemetry to help us recover from any kind of a breach. As we look back at the conversations we've had with customers about Zero Trust over the years, many of those conversations are about, kind of a long rollout plan and thinking through what's the strategy and how am I going to build out to this. But of course, in March, everything changed. And these 2-year plans suddenly became 2 and 3 week plans. And so many of you were vaulted forward into your Zero Trust deployment. And for some people that went really well. We did have some customers who'd embraced the philosophy, who were, saying things like, for us, it was essentially a no-op because we had already set up, assuming that any request could come from anywhere and that we had to be explicit about the verification. So that worked out for some folks. When we look at the surge in cloud authentication that came concurrent with the pandemic, it was, a huge impact in terms of the volume we saw in our traffic. So we could really see people shifting rapidly to the cloud and embracing Zero Trust.
Let me walk you through a little bit of what we heard customers experience during COVID. Starting with, how were they going to get their employees to actually work from home? And for some customers who were still on premises using VPN on premises, they hit a real challenge with getting their VPN to scale. And so many of them had to look at additional options to help support that transition. A whole bunch of customers then were in this category where if you were in government, you were looking at how do I scale up my unemployment system to support the large number of people who signed up. In the banking sector, we saw huge surge in small business loan applications. For healthcare sites and for government responsible, we saw a big surge in how do you enable some websites that can help people identify symptoms, find COVID testing centers. And so we saw a whole series of new apps that needed to be created very quickly. And unfortunately, we also saw the bad actors come out. And what we found with them is that for DDoS, for example, during March to June, we saw a 50% uptick in DDoS attacks. We also saw increased phishing attacks across the board. And in addition, what we saw was customers were really looking at retail customers in particular, were their framework for traffic was, I have a Black Friday now every day, and my new Black Friday moments, I have to plan for another scale dimension. And so they were really like, how do I deploy enough resources so I can handle that spike in demand? And also, how do I make sure that that is done safely? And in Azure networking in particular, we saw about a 90% increase in our cloud native network security capabilities during this time.
In identity as well, we saw a big uptick in attacks on users. We saw everything from credential stuffing to password spray to phishing attacks on the rise. And in some cases, really substantially increased. So it shows that while we were very focused on enabling our workforces to be able to go and work from anywhere and still have that same productivity, we couldn't take our eyes off the ball in terms of security. And that's, where, again, Zero Trust really plays well, because done right, Zero Trust can enhance your productivity and enhance the security. One of the things that we've been talking about is kind of a napkin diagram for Zero Trust. And so when we think about the simple model here, and Sinead will talk more about the application of this in many different environments, but I'll kind of start with a simple example. If I have a user that I have sent home, and that user needs to get to a resource that is a corporate resource, like something like SharePoint, right? We kind of have this concept that the user needs to be able to get to that file. And, unless the user has been implanted with some sort of, matrix-like chip, they're going to need a device to do it with, right? So they're going to have a laptop or a tablet or whatever that they can go in, reach out and get to that file with. And of course, there needs to be some communication pathway between that endpoint and that resource. Right, so here's our major players. When we talk about explicitly verifying, we can explicitly verify who the user is, the kind of device they're on, the pathway they're taking, the kind of resource they're accessing. And when we talk about least privilege access, that's where we need to insert a zero trust policy that sits in the middle and takes all of that context that we just talked about the request, and then can enforce controls to get that least privilege access approach to security here. And then again, maintaining that humility, we assume that things can go wrong, so we're going to invest heavily in making sure that we capture all the intelligence we can from every element, and we do as much automation as we can to promote a rapid response. Sinead?
So now let me dig in and get a little bit more deep into the zero trust model. First of all, this is a reference model. This isn't it's not a precise system. And so, but what we want to highlight is that for the 4 pillars, there's a lot of context that you can get from each one. And so I want to walk you through a little bit what you can now get. So if we look at identity, there's one which is about the user, or it could be an employee, or it could be a partner. So it could be very people-centric. But it also can be very appropriate in the infrastructure setting where we're looking at machines, we're looking at services, or in Azure, we're actually looking at the subscription, which is the environment in which maybe a certain budget responsibility lays for a set of resources. So that's identity is actually a broad kind of concept. And similarly on endpoint, my way of thinking about this is it's where is the compute power that's enabling either the user, or it could be enabling that service to run. And so it could be on an IoT device, it could be on your mobile phone, but it also could be a server, or it could be even a VM. So again, think of endpoint in sort of that larger context. And then there's networks of different types. You can think of the physical network, whether it's Wi-Fi or wired, but more importantly, is it your managed, or is it the internet and it's completely untrusted? It can be a virtual network, so it can be a network that stretches and be an overlay on top of existing networks as well. So again, all of those are applicable, and that you can create different policies depending on the situation. And then lastly, if you look at resources, this is really anything that you want to access. And it could be a device if it's in the case of machine to machine, or it could be an application, whether that's running an IaaS or PaaS or serverless, and also no matter where that application is located. So what you find then is these pillars, the insights from them, can be combined together to give you a lot of context on the access request. And as we go forward, we're going to make this even richer. And so if we look at identity, you can say, hey, is this what FQDN, fully qualified domain name, am I connecting to? What service is this? What's the role of the person who is making this access request? So that might be something you might look at. On the endpoint, you might say, is this my managed device, or is this completely untrusted? On the network, you might say, is this, the internet? Could this be from a bot network, a known bot network, or a known command and control center? And so again, is it anonymous or is it known? And so you can have this kind of context. And similarly on the resources, you can say, well, is this resource a high classify? Is it you classify it as high value data, or is it just your cafeteria menu, as an example? And then with context, you can also get even richer insight. Like you might say, based on a number of contexts, the risk level of this communication pattern is this. Or you can look at that pattern and say, hey, it's anomalous, so maybe I should do some extra inspection. So there's a lot of you can apply by using the data from these pillars to then make smarter decisions. And then when you look at the controls that you might apply, you might, depending on the context you've collected, you might say, hey, I'm going to challenge the user and I'm going to require, them to sign in using a different method because it looks a little off for me. So I'm going to trigger MFA. But it could also be, this pattern is a little bit unusual. I'm going to rate limit because this has the look of a DDoS attack, but I don't know for sure. So I'm going to just constrain it so that it doesn't consume all the resources of the server, for example. Again, the controls are quite rich as well. And what's really important in this model is it's not a one-time decision. We're really recommending that you are looking at these signals all the time and then continuously verifying and pulling access if it's not meeting your criteria, or enforcing another control to make sure you're safe.
Awesome. So let's bring this down to a really simple example to kind of illustrate the point. So going back to that day that we had to send everybody to go work from home, right? We might have a rule like this, which says, hey, if a full-time employee is on a specific type of device that is known to the network, right? That's domain joined, and they are on an untrusted network, right? Now we can use that context to synthesize additional, so we can say, and there's no other risk anomaly present, and they're trying to access their email, let's just require them to do multi-factor auth, right? So simple example of a really core zero trust policy that probably many or most of you are using today. But Sinead's going to show us how we can take the same model and extend it a bit.
So Alex just walked us through kind of that user to resource access. And I'm going to take that another step further. And I'm now going to assume that it's a user and they've accessed an e-commerce web application. And so the same controls that Alex just talked about, that applies. But now I'm going to look at what happens to that. What type of zero trust policies might you apply to your infrastructure and to that web app so that it can talk to that SQL on premise in a safe way, in a highly appropriate one that uses the zero trust principles. So the first thing you might say is, what are the kind of identity contexts you might have? Here you might have some things like, what is the services that you're using for your web app? And in this example, we're using app services. We might say, well, what source IP do I have for the SQL server on premise, but also for the web app? And what you might use there is you might have a private IP that you've used something like private link to give that web app, so that all of the communication pattern between the on-premise SQL and the web server is not over public IP. So you would have to be on that actual network path to be able to see that communication. And then you might say, well, what are the types of networks? In this case, the web app is on the internet, but it's also got a secure path back to on-premise, maybe through a VPN or ExpressRoute. It's also, that web app is on the virtual network, but only the app services, the end users cannot connect to that on-premise SQL. There's a layer of isolation there. And so this context then can be used to create some rules around, well, we don't want no internet to that SQL server on premise, except it does need to get to github.com or Windows Update. So a very simple way for you to say, hey, I do want to allow that SQL server to get some internet access, but nothing, only the rule, the specific request I want to support. Another thing that you can do on the context is you might look at the traffic and behavior that's flowing between that SQL server and that web server. And again, we would look at sort of the volume of traffic and the frequency. And if there's an anomaly and it's out of scale, we might say, hey, hang on a minute, could that web server have been intruded into? And maybe some of the things you may want to do is take that specific web server out of rotation if we thought it was compromised in some way. So that would be an example of a control that you would do that might isolate that resource. And in other cases, we might say, hey, actually, I want to fire an alert right away to the SOC to say, there's something unusual here, I need you to investigate. So there's the sort of examples of some controls that you can put in place. And then for that on-premise resource, we're really looking at how do you reference it. And one of it might be its private DNS name, but it also could be, well, what port and protocol is it exposing, and as well as the private IP. So all of this combines to give you actually quite really nice, simple policies to express your communication pattern, but also an ability to use a lot of rich signal as part of the access request. So now let me dig in a little bit deeper into the actual, how do you take it now to the next level of advancing your protections at the network layer. So we published a maturity model as part of Microsoft's Zero Trust response. And what we found is that customers typically found themselves in each pillar to be in different stages of maturity. And then the other thing that we sort of saw as customers get more advanced is they're using more cloud native filtering capabilities and more advanced threat protection capabilities. And here what we find is when customers embrace that infrastructure as code mindset and they have rich deployment models that stay fresh with the application, and as the application is advanced and the actual network security rules are advanced at the same time and it becomes part of the app deployment model, we found that customers are actually more mature and have more protections in place. And the other part that we sort of see as customers go on this journey is that user to app mindset is they actually go to having all users to apps, and especially for their internal apps, also enabling encryption for them, maybe also enabling encryption in their infrastructure, which is very easy to do in their cloud infrastructure, for example, today, or from their cloud infrastructure back to on-premise with our cloud native network security tools. And then when we go to this optimal stage is really where customers are fully distributed. They really have embraced this full segmentation, and they've even gone to full micro segments. And you could even go to having rich layers of segmentation, all code driven, a lot of use of ML to define the rules. And then each layer in the system, you have layers of encryption as well. So what does this look like if you take, what are the controls that we give you today in order for you to achieve zero trust? And so I would sort of say there's kind of 4 layers of controls that we provide in Azure networking to enable you to be successful with your journey. The first set is kind of what are the rich network security services that we offer inherently. And these are services that are cloud native, they're auto scalable, they're managed by Microsoft. And so customer just needs to configure the policies that they want to apply using them. So the first one is Azure Firewall, which is all about traffic governance. It is a full next generation firewall, but it works across VNets and across subscriptions, and it works across clouds as well. We're the only public cloud provider to provide this today. And then the second service that we provide is Web Application Firewall, which is specific to web applications. How do you protect against data exfiltration? How does SQL attacks like SQL injection? How do you rate limit? How do you apply sort of specific policies where users may be trying to break into the application? And then the third rich service we provide is Azure DDoS. And recently we're up the level of protection, so we can now protect up to a 47 terabit per second attack. So that's our network security native offerings. Then we also offer a rich set of network connectivity options, again, that are all cloud native. And that's sort of across sort of, I would say, 2 dimensions. One is pure connectivity, and I encourage everyone to look at virtual WAN, which is our software-defined WAN offering that works with SD-WAN vendors and ISPs for last mile, but it uses Microsoft's backbone that allows you to embrace a software-defined network model. And then the second one I would say is take a closer look at Azure Front Door, which is our CDN. And this is also a global load balancer. And this is where, how do you optimally enable your apps on the internet? And then everything we do is we use software-defined networking. Everything is API-driven in Azure. And so we offer our whole entire global network in 74 countries is all software-defined. And we offer a number of controls here that are, again, there to enable you to set up a secure infrastructure from virtual network to private link. And then we do believe in a defense in depth model, and it's not all Microsoft. It's really important that we make it easy for you to add partner solutions as well into our operating model.
So when we look at all of the things that Sinead talked about, and then the core user trying to use their laptop to get to email, you start to see this picture evolve where the road ahead is to extend beyond just looking at how users access resources, but really thinking about how every part of your infrastructure interacts. In any kind of interaction, whether it's a VM calling another VM to compose a service, or it's a user calling to a web endpoint, you're still going to have this basic model, right? Where that in each case you want to verify the elements of the request. apply your policy, and then assert your controls to make sure that what's happening is exactly what you intend to have happen. And Microsoft across the board, whether it's things like endpoint compliance or identity assurance or networking controls, has a suite of tools that map into this model fairly elegantly. So the road ahead in some sense is to extend whatever it is you've done, extend to that next step and start to explore those things. As we talk about these pillars, the pillars of identity and endpoints and networks and resources, one of the things that is really interesting when we look to what we're going to be doing on the road ahead is to look at how these pillars begin to intersect. So while we would encourage you to start exploring the things you can do in your zero trust journey across these pillars now, we're working together across the networking, identity, device, and other teams to make sure that these experiences become more and more stitched together for your zero trust journey. And I want to give some examples of what we think some of those things might look like going forward and where you can start to see it showing up now. And so one of the things that's really interesting is that as we look at these requests, very often the initial request gets set up, but we don't have a ton of insight as a policy decision point. So for example, in conditional access, we may not have insight into the conversation that's happening between the client and the resource. And so one of the things that's really cool is that we can start getting into continuous evaluation. And there's a standard called CAPE that's evolving, and we've recently done sort of an early implementation that we've begun with Teams and SharePoint and such, where we actually get this conversation going, where the various pillars start to talk to each other and provide a much richer experience. So if I can, as a resource, say, hey, that's strange, the last time that client made a request to me, the pattern was very different, or they're downloading a lot more data than they usually do, or the network they're coming in from is very strange. Why don't you go reassess the policy and actually send back, in this case, to the identity provider for policy reevaluation? That's a very powerful model where we can move from waiting for tokens to expire and then checking again to getting near instantaneous assertions around policy enforcement. So that's one really interesting area that we're exploring and that you can start seeing and taking advantage of now. Another area sort of that's similar to that is what happens when the resource and the policy engine can have a conversation that can say, for example, the policy engine can say, hey, look, given the context of this request and all the things I verified, I'm okay with you having the connection, but I want you to give less service than usual. Don't allow high risk operations to happen. So you can see early examples of this with SharePoint limited access, where you can set up a policy that says, given the context of a given request, I don't want to allow things like download, print, or save, so I can make sure my data stays safe on the device. And another example of this is where we start to think about the opposite conversation being true. So sometimes the resource has a sense of what's going on that is more than you can really express deeply in the policy engine. For example, I can get to a specific file and say, hey, this file has PII in it, or it's classified in a certain way. And if we can go back and actually start to say, give me a grant that is appropriate, or find a policy that is appropriate for this level of access, then we have another leg in the stool. So we have multiple conversations that are going between the endpoint, the device, the network, and the resource that are all helping us get to a more advanced, and I like to say a tighter weave in our security journey. Many of these things are going to depend on standards that we're going to develop for many, many years. The standards process is not super fast, but it is super powerful. So when we look at standards like FIDO or more emerging standards like CAPE, the good news is that at the end of that, it works across all of the investments you have, right? It's a multi-vendor strategy, which is super. There's a long tail here, and this is another place where the network can play an important role. So when we think about, currently an appliance like, something that can do break and inspect like MCAS, we can start to actually look at that as a way to bridge into applications that might not know how to do the more advanced things. So I might want to have a conversation that says, hey, if the IP address changes, reevaluate that policy. Even if the application can't do it, those break and inspect proxies can. And so that's a really interesting thing that we think is going to evolve as we go forward. And then Sinead is going to bring us home talking about some of the infrastructure going forward.
So thank you, Alex, for walking through some of the security contexts. I'm going to now layer in some of the network security controls. And please don't be overwhelmed by this slide. It looks more complex than it is, but it is a pretty good representation of what customers do today in Azure. And what they tend to do is most customers embrace kind of a hub and spoke model for their network security controls. And they put all their shared services, these are the services that are used by everybody, into a specific hub VNet, they call it. And this is where you would typically deploy your WAF and your Azure firewall and your DDoS protection and your Azure AD and your key vault, all in this kind of shared hub. And then you would put your apps into different spoke VNets. And then if you look at the model, there's sort of a north-south of traffic flow and an east-west of traffic. And you can then use that shared services environment to restrict the connectivity, to allow and to isolate the resources. And so what we'd see from the north is traffic would come in from the internet. It would come in at our network POPs in Azure, and that's about 170 of them right now. And this is where we would apply WAF policy at the network edge and block the attacks close to where they occur. And so that's sort of the inbound. And then when it comes into the Azure regions, then you would see us, sometimes we would do some regional WAF policies as well. But we would also apply DDoS protection both at the edge and again as we come into the region. And then this is where we'd also have Azure Firewall, which would be, controlling what traffic is allowed in and what traffic we want to allow outbound as well. And also we would see with Azure Firewall what is allowed to flow east-west from a spoke VNet into another VNet. And then in the southbound, we might look at what traffic is coming from on-premise, and that could be via virtual WAN, which would be the branch connectivity, or it could be from mobile users, or it could be from ExpressRoute. And so fundamentally, these network security controls, what I see customers do is sort of they fall into one of two camps. One is about the secure infrastructure, and that's where they use these software-defined network controls like private link and VNet to set up the infrastructure for their dev teams. And then they use the network security controls then to in conjunction. And then that helps them to enable sort of a set of specific use cases around data exfiltration or central management and auditing and logging of all communication, or maybe put some data exfiltration controls into place. And so that's sort of one set of sort of infrastructure security. And then on the other side, we see customers and they're looking at, well, actually, how do I enable user access, or how do I optimally enable the application to be accessible for our users or from other systems? And that's where they combine the sort of connectivity services like Azure Front Door or Virtual WAN or ExpressRoute, and then they combine that with our network security services again. And what they're looking for here is they're really looking at, I want to be protected, yet I want to have a best experience for cloud. I want to enable optimal delivery of the application in a scalable way so the application is protected and won't be broken, or data won't be stolen from that application, and that application will continue to operate no matter what type of attack it may face on the internet. And so we see customers do both of those models.
All right. And with that, we'd like to leave you with a few resources that you can use to sort of extend this journey yourself. We have built a core Zero Trust page at aka.ms/Zero Trust, and that has pointers to all the docs below. There's the maturity model that Sinead alluded to at /ZT model. There's an assessment tool you can take to kind of assess where you're at on your Zero Trust journey at ZT tool. And then something I'm very pleased that we've done is a set of deployment guides for if you're a device administrator or an identity administrator or a network administrator. You can look at these deployment guides to get concrete configuration guidance to help you along your Zero Trust journey. And so you'll find those at ZT blogs. And then finally, I'd like to plug Sinead's next other talk, which is 0D202. And that's protecting remote work and digital experiences using the cloud native network security. So be sure and catch that talk. With that, I will remind you to verify explicitly, use least privileged access, and assume breach. And thank you so much for your time today.
Yeah, thank you everyone. Have a great rest of the day.